Hello. Last class actually I was explaining to you about the minerals, the definition of a mineral, and also briefed out about the importance of a mineral. What is the importance of a mineral? Everything I explained. Now I have to identify the minerals. How to identify the minerals? There are the properties. To identify, there are the properties of a mineral. See, there are how to identify. One is physical properties. Chemical properties, optical properties, and special properties. These are the ways to identify the minerals. The physical properties is nothing but we are going to identify the minerals with respect to the physical appearance, the physical features, okay. The chemical properties which we are going to identify by using the instrument. How we are going to use the instrument? Well, we are going to do powder XRD. In the powder XRD, we can able to know what is the chemical composition which is being present. And also we are going to use ERAX and EPM. ERAX means elemental dispersive analytical X-rays. EPMA electron probe micro analysis, where we can able to see what are the elements which is being present in the mineral. This is how we are going to identify the chemical properties of the mineral. There are some procedures. See, with respect to the syllabus, we are having only physical properties and the special properties. In the optical properties, we are going to identify the mineral optical features, means by using the microscopes, and we are using to identify what are the internal structure which is being arranged by the microscope by using the optical property. Special properties, we are going to use some minerals which is having some special properties. Some minerals having the magnetic properties, some minerals having the smell and taste, some minerals having the odor test. These are all some special properties which we are going to identify. These are the 4 ways to identify the properties of a mineral. With respect to the syllabus, today I am going to explain the physical property of a mineral. In a physical property of a mineral, see, in physical property of a mineral, first thing I am going to identify the habit, or it is also called as form. Means external, how it is. Today I am going to highlight only about this part. In next one is color. See, there are, here I told, there are 4,000 minerals has been discovered so far. All minerals which is having different types of colors. So that is what we call as the color. Next one is streak. Streak is nothing but, see, just I am explaining, just I am listing of this physical property. In every classes, I am going to explain, I used to elaborate all this property. I am going to explain. Streak is nothing but, there is a porcelain plate. There is a plate called porcelain plate, or it is also called a streak plate. Say for example, if through the naked eye, the mineral may exhibit one color. If it is a green, okay, when we are going to rub with the streak plate, then the color will change. That is the property of the streak. Next one is fracture. Fracture means if any fractures, any cracks which has been appeared on the surface of the mineral, that is called as the fracture. Next one is hardness. Hardness means the mineral which is having how it is able to scratch on the surface. Whether it can be easily scratched, or whether it can be scratched through some other objects, or some minerals it cannot be scratched in any other object. That is the property which can be determined by the hardness. Next one is cleavage. Cleavage is nothing but the tendency to break the bonds by using hammers or using the stronger objects, anything, and how that minerals able to break. That is the property what we call it as the cleavage. Next property is called luster. Luster is nothing but the amount of shininess which is being present in the mineral. And next property is diaphanity. Diaphanity is nothing but the amount of light passes through the minerals. The property is called as the diaphanity. And finally, which is the specific gravity. The specific gravity in the sense how the elements which is being present in the mineral. So these are all the properties which you are having in the syllabus. Okay, just having briefed out about the importance of the physical property. Now, in this class, I am going to explain habit of form. What do you mean by habit of form? See, I am holding 4 minerals. This is one mineral. This is one mineral. This is one mineral. And similarly, this is one mineral. So, with respect to the external appearance, the shape of minerals varies. In this mineral, it doesn't have any shape. It doesn't have any shape. So, we call it as the massive. If we consider this one, it is tabular in shape. If we consider this is cone in shape, again it is elongated. If we consider this is the flattened and this is, we call it as laminar in shape. Okay. Again, based on the shape, it is being subdivided into 4 categories. Which is that? One is tabular, laminar, granular, and imitative. Tabular, let us see the tabular. These two are called as the tabular. In this mineral, see here there are 3 axes, A, B and C. In the earlier stages you are going to, when you have been studied the crystal axis of, there are 7 crystal systems. I am not going to explain much about that. In that 7 crystal system there are 3 axes, A, B and C. Okay. If one axis, if we are going to fix this is a A axis, the growth rate in the A axis would be more compared to B and C axis. Okay, just I have been briefed out. In this case, what happened? In one axis, the growth rate of the mineral is higher, and another 2 axes, the growth rate of the mineral is lower. That is called as the tabular form. Okay. Next, let us see. You can able to see. With respect to that minerals, this shape is laminar. We call it as the laminar. It is horizontal in shape. What we can able to consider, the axis of A and B is lesser, and the growth rate of the axis is C. Similarly, this shape is called as the laminar in shape. And also, whether it is a laminar or whether it is a granular. See, earlier what I said, this is massive. This doesn't have any shape or it doesn't have any structure. Okay, so that's why we call it as the massive. Similarly, whether it is a massive, whether it is a lamellar or whether it is a tabular, in the surface of these minerals there will be a shape. You can able to see the determination of the grains. The grains are being protected like this. Whether the grains would be in this shape or whether the grains would be in the lesser shape, we call it as when the presence of the grains in the surface, then it is being called as the granular. It is being called as the granular. Next comes under imitative. What do you mean by imitative? It is an imitation. It is an imitation. Say for example, first one thing I am going to write. Say the thing is dendritic. In the minerals, it is a best example, whether it is which is in the form of chelt. It is a quartz mineral. The shape would be somewhat like branches of leaves. So it is been imitative, then the name which itself is dendritic, means it's a imitative. Okay. Next one is amygdaloidal. Amygdaloidal is nothing but when the lava erupts, the pores will be going to see in the surface of the minerals. Well, in that pores, the new minerals will form. Say for example, if we are going to take a cross section, there will be a vesicles. That is a pores. That pores is called as vesicular. The same vesiculars filled by new minerals, which is being filled by the new minerals, that is called amygdaloidal. Only the pores is called as vesicular, and the pores which has been filled by the new minerals is called as the amygdaloidal. Okay. Next one is oolitic. See, I am explaining about the imitative. In the imitative, I am going to tell oolitic. Oolitic is nothing but in the sample, which is the surface itself will be having the, means in the surface it will be the oolitic, the minerals would expose, the grains would be outer surface. It could be not in a flux, that is in a ball shell, that is called as the oolitic. And also it is zeolitic. What do you mean by zeolitic? Zeolitic is nothing but the holes which has been having a curved, that is circumference nature. The best example for the zeolitic is laterite. Laterite is a sedimentary rock which is being usually found in the coastal regions where the pores would be more. And finally, I am going to talk about the radiating. Radiating means the sample itself, it is a one portion which resembles like a tree-like structures or like a plant-like structure. This type of samples which we are going to see in one part, then that part is called as the radiating. In the imitative, there are varieties, that is dendritic, amygdaloidal, vesicular, zeolitic, oolitic and radiating. Okay. So, in this class what I told you is how we are going to identify the minerals. The identification of minerals is physical properties, chemical properties, that is special properties and optical properties. With respect to the syllabus, we are having physical properties and special properties. In the physical property, I have listed out around 9 to 10 physical properties, and in that part today I am elaborating about the habit. In the habit again it comes under 4 categories: tabular, lamellar, granular and imitative. Tabular means when the minerals are long, that is elongated to each other, that is called as the tabular. When the lamellar, which is flattened in surface, that is called as the lamellar. Granular means whether it is a lamellar or whether it is a massive or whether it is a tabular, in the surface we are going to see the arrangements of the grains, that is called as the granular. Imitative means it can be imitated to any other object, then that is called as the imitative, whether it is dendritic, amygdaloidal, vesicular, zeolitic, oolitic or radiating. Thank you.